A relatively easy way to create a data frame is to actually read the data from a file. One can do that by using a base R function called read.csv. I have a CSV file providing the temperatures in Central Park present in the data file in my working directory in R called centralparktemps.txt. And so I'm going to be creating a variable, a data frame called cpt data, and I'm going to be using the base R function read.csv, and I'm going to be providing the name of this file. Please note that this file is in the same working directory as the script fundamentals_ds.1, and so I would not actually have to specify the path to this file. Another option I want to set right now is the fact that this actual file has headers, and so I'm going to specify the header as true in the sense that this CSV file has the first row that are column names. And so if I run this, one notices that I have in the global environment data frame CPT data with 1765 observations of 3 variables. If I want to take a look at this file, I can visualize the dimensions of this file, the structure, the head and tail of this file. Before we do that, however, I want to also mention that we don't actually need to have the file downloaded for us to be able to work with the file. We can also use the file that's present on a URL. And so I'm going to be creating another version of this data frame, cpt data underscore URL, to indicate that this data frame has come from a URL. And so I'm going to be using read.csv, again the base data function, but instead of centralparktemps.txt that's present in the local directory, I'm going to be providing a bit.ly URL. And this is the bit.ly URL, and it is the same file, but it's just present at a remote location. And I should be specifying header equal to true because it is in fact the very same file. And if I do that, you notice that it takes a few seconds because the file is coming down from a URL, and you see that the data set is the same. The global environment cpt data underscore URL still has 1765 observations of 3 variables. What we can do now is examine the structure of this data. We can do that very simply. First of all, by typing in str of cpt data. We can do that to either cpt data or cpt data underscore URL. They're both the same. And so if you take a look at the structure of this data frame, we see that there are 3 variables, year, month, and temperature. The first 2 are integer values, whole numbers, and the temperature is numeric data type. And we have values starting from 1869 going all the way up, month from 1 to 12, repeating, and we have temperature values in the temperature column. We can actually take a look at the dimensions of this data frame by typing in dim cpt data, and we see it has 1765 rows, 3 columns. We can take a look at the head of this data frame, and if you do that, you get the first 6 rows. And if you do tail, we get the last 6 rows. And we see we have the last row as January 2016, and we have the last 5 months of 2015. Now that we actually have a data frame called CPT data, we can examine the use of other base R functions and see how they can be used to work with data in a data frame. One of these functions is a function called subset. Subset allows us to extract from a data frame or a vector parts of it that meet certain conditions. For instance, if I want to, from CPT data, retrieve only data for year values equal to 2000. So I only want to return year values where the year is 2000. I might use the subset function and say from CPT data, retrieve for me where the year values are equal to 2000. Now, if I run this by itself, I will find that this function lists what these year values are. This doesn't really help us because we're not doing anything to this data, we're not storing it anywhere. So I might want to then say, store this result of the subset into CPT 2000. And when I do that, I can then see CPT 2000 stores the data. In fact, I might be interested in not just the fact that I want all the columns. Maybe I want only the month and the temperature columns for the year 2000, not specifically the year column. This allows me to do something slightly different. Again, just working with CPT 2000 as the data frame that I'm going to be working with. I can say subset CPT data, grab the year, where the year value is 2000. Please note that I'm using 2 equals to signs instead of 1 equal to sign, and the reason I'm using 2 equals to sign instead of 1 equal to sign is because 2 equals to signs represent comparisons and a 1 equal to sign would represent assignment. And I'm going to be selecting the specific columns I'm interested in. The specific columns that I'm interested in are month and temperature. Once I do this, I'll find in CPT 2000 I have month and temperature columns only and no longer the year column, because obviously the name of the data frame suggests that this is the year 2000. Now, one of the things to note is that we have temperature, which is generically specified, but this temperature actually does have a certain value. This temperature is temperature in Fahrenheit, not in Celsius. So one of the things that we might be interested in doing is actually changing the column names for CPT data. And one of the ways that I can do that is, again, by using the call names function. And the call names I'm going to be changing is going to be changing for CPT data. I'm going to change the column names of CPT data to the following. I'm going to make it year, month, and I'm going to be referring to changing temperature to temp F. And if I then take a look at the head of CPT data, I'll see that the column names are year, month, and temp F. Now, while temperature in Fahrenheit is in fact a defined way to measure temperature, most of the world, in fact the rest of the world, does like to look at temperature in Celsius as well. Consequently, what we can do is try to convert or create a new column that gives us the temperature in Celsius as well. To do that, we need to perform a conversion, and so to do that, I shall be creating a function. And so I'm going to be calling this function F to C, Fahrenheit to Celsius, and this is a function that requires a temperature in Fahrenheit. Once it receives a temperature in Fahrenheit, it will return a certain value. It will return the temperature in Fahrenheit minus 32 degrees multiplied by 5 divided by 9. To store this function, I'm going to select the entire length of the function and run those lines. And we notice that I have a function listed over here called f2c function tempf. To create a new column in the same data frame cpt data, I shall be saying cpt data, and I'm going to be creating a new column called tempc. In this new column, I shall say that I'm going to be running this f2c function on cpt data, and specifically the tempf column of cpt data. Once I do this, I can inspect cpt data once again, and I see that cpt data now has another column called tempc that holds the Fahrenheit version of the temperature in Celsius. Do notice that this tempc has many decimal points, and so we can use other functions to round these out if that was something that we were looking to do. If I now wanted to do something with this data, such as write this out to another file, or write it back, in fact, to the same file, central park temps, I can do that. And the way I would do that is by using the function write.csv. If I wanted to write this new version of CPT data out to a file, I could use the function write.csv, and the data frame I've got to be writing out is going to be called CPT data. And I want to write this file out to a specific file, so I'm going to specify the name of the file. I'm going to call this CPT data F and C, so it holds, and I'm going to call this CSV. I do have to specify a separator, and so I'm just going to say the separator is going to be comma, and notice that every time I've been printing out CPT data, I see a 1, 2, 3, 4, 5, 6 on the left hand side over here. These are in fact row names, and I'm not actually interested in these row names being saved because they're just positions of different rows. And so I'm going to say that the row names is false, and so do not save the row names in CPT data underscore F underscore C. I'm going to write this file out. It's saying that it's going to be ignoring the separator, and really the reason it's ignoring the separator because it's already going to be a CSV file. If you wanted to take a look at this data frame, you could actually click on this data file and you can view the file. And when you view the file, it shows up in the window right here. We see that we have year, month, temp F, and temp C all listed out, all the rows listed out right here.